All right, this is the slide we just got done with, so we'll move on to the next one. This is a schematic of kind of how a hydroelectric dam works. You don't really necessarily see what's going on with it. The generator or the intakes for the water will come in from the bottom where it's under high pressure because of the column of water above it. And this will go through a turbines, which of course is just like a coal-fired power plant or nuclear power plant would work as well. So it spins this turbine and generates electricity. These are very efficient because, of course, you're really not doing a lot of energy input. You're taking advantage of kinetic moving water that's doing it anyways. So again, if you have this potential, it is an excellent source of perpetual energy. And again, there's pros and cons to using hydroelectric, but this is definitely a pro. And they use quite a bit of this out in the western part of the country where they have some large water reservoirs for generating this electricity. Here is a problem that we're looking at currently. This is Lake Mead, which is with the Hoover Dam. And you can see what it looked like in the year 2000. This is kind of facing towards the dam, looking from Lake Mead, where the water level was. And you can see on the right-hand side where it has been most recently. And that's like a 120-foot drop. I think that's the number I heard. It doesn't necessarily matter a whole lot, but it's quite a huge difference. And there's two problems with this. One is a reservoir of water, which is no longer there, at least currently. And two is if the water gets much lower, they're not going to be able to generate electricity. And we can kind of see this in this little schematic here, looking at as far as how the water level has changed. And you can see where it has been and where it is at now. You can see it's the lowest level it's been in like 90 years or so. And if it gets too low, roughly 900 feet, they're going to have some serious problems because they're not going to be able to generate the electricity, which is something, of course, the reason it was built in the first place. Wind power is one of the two big newer energy resources that we are currently pursuing. I believe that is wind is the fastest based on new production energy resource that we are pursuing in the country. And we have a lot of potential in the country, specifically in either on the coast of east or west or in the central plains of the country. So right now we're only getting a smaller portion of what is available to us. We're going to do an activity in class. We're generating some wind energy, and we'll look at all the ins and outs as far as what makes a location good for producing wind energy and what are the factors of a turbine that are useful in generating electricity. You can see how the United States has actually fallen a little bit behind in the production, not just in putting up the towers, but all of the resources that go into making the wind turbines. There's a lot of materials called rare earth metals that are useful in the electronics of wind turbines, which we have lost some of the rights to in the last 20 some odd years. So we're a little bit behind a lot of the rest of the world in producing wind energy. Biomass is fairly carbon neutral because you're using materials that can be replenished in a shorter amount of time in comparison to fossil fuels, which are more geological and you're not getting those back. You're not replacing them. So although you are creating a CO2 output, these resources can also go back and use the CO2 to produce a biomass again. And this just gets more into that conversation, which I'm not going to go and read through those, but you can see some various examples of them. Same idea, just more of different types of biofuels. Some are solids, some are in a liquid. Ethanol is probably the one you're most familiar with, which comes from corn. If you have excess corn laying around, you might as well produce an ethanol out of it. But we have shown that if your goal is to try to generate a liquid fuel source in place of petroleum, you're better off using something called biodiesel, which comes from typically soy. you're going to get more energy out in comparison to the energy in. But neither one is necessarily a good pursuit because you're putting more energy into the process in comparison to getting it out. And there's other environmental factors that go along with it. But you can have some kind of a conversation about any energy production. But there are some definite downfalls with biofuels. This is the ethanol we were talking about already, so you can pause and take a look at this. I won't spend time going over these couple of points. Geothermal. There's two different styles of geothermal. There's commercial usage, and for that to really work, you need a location that has some geological activity in the form of hot material below ground. And a lot of the United States does not have this available. There's some places out west in which you have it. There's, of course, places in Greenland. There's places, I think, in China that are able to take advantage of having very hot geological materials near the surface. You can use a process which is sort of similar to this. It's called a heat pump, which is a geological process, and that is going to be shown on this slide here. But typically, you're going to need a little bit more real estate. So if you have a typical city lot, it's not going to work so well. But you need some space to make this heat exchange. The ground is always at about a similar temperature. Call it 50 degrees. So in the summertime, you can remove the heat from your house, just like your refrigerator does, and place the heat in the ground and get a cooling effect in your house from what's in the ground. That cool air, bring that into your home. In the summertime, it works exactly the same. You can extract that heat, which is in the ground, 50 some odd degrees, concentrate it, and push it into your house. So the opposite process of what a refrigerator does in cooling a space, you can do it to heat a space. These are quite efficient depending on the resources you have for heat. If you were having to use propane to heat your home or heating oil, this would be something that would be more advantageous to use a heat pump. I'm not sure economically it is a better idea if you're using natural gas. Using hydrogen as a resource, this gets into the idea of fuel cells, and we have a schematic on the next page for your car. This is another one that's sort of like fusion, not to the extent of fusion, but we can get it to work, but it's a little bit expensive. And the way that the hydrogen has been produced traditionally is you're not really escaping the whole fossil fuel problem. A lot of times they use natural gas to obtain the hydrogen. If you were using wind energy or solar energy to produce the hydrogen, then that would be a better idea. But it hasn't gotten to that point where the efficiency has gotten where we can just get the hydrogen without the carbon footprint of its generation. But fuel cells is another item we're looking for a breakthrough where it becomes economically feasible to bring this into our energy portfolio. And this is a schematic in which they're using it for a car. These do exist, mostly out in California, but they haven't gotten to a point where they're economical again for everyday usage. All right, I like this slide as far as just looking at time, a long time, well, the last 200 some odd years, and how our energy profile has changed. So if you go back to 200 some odd years ago, pretty much we used wood, biomass. If you wanted to heat something, you burned wood. And then, of course, we eventually transferred over to coal. And what I find interesting when we look at like the nuclear towards the bottom, you can see where it started. And this schematic, as they're predicting, is eventually it will peter out. We won't be using it anymore. And even looking at something like natural gas, you can see how we're peaking on that right now, close to it. And the prediction is that eventually will go down too, because it does have carbon footprint. And then just kind of trying to focus on other resources with the hydrogen or solar. And wind should probably be in there somewhere as well. Okay, so looking at a sustainable energy strategy, there's a few things that we need to do is how we're obtaining our energy and how we're spreading our energy. So right now we've heard the word grid, and for most of us that doesn't mean a whole lot. I want to say there's three main grids in the United States. There's an East Coast, a West Coast, and Texas. There might be four. I forget if there's a central one or not. But one of the things that legislation has been changing with in the last so many odd years is trying to fix or make the grid a little bit more smart. And we'll get on that, I believe, on the next slide. I think we're going to take a pause here, though, based on the time, and we'll pick it up on the next one.